Let's look at how big a mole is. So a mole is, as we mentioned, 6.02 times 10 to the 23rd objects. For our example here, we're going to use a mole's worth of moles. And for our mole, we're going to say that he is about 15 centimeters tall. Or long, and for his height, we're going to say he's about 5 centimeters. And his mass would be about 150 grams. So a mole's worth of moles. So if we had 6.02 times 10 to the 23rd moles, we would have a lot. Obviously, the times 10 to the 23rd says we're going to bump the decimal 23 times to the right. So if somebody were to give us a mole's worth of moles, it would be a very, very big pile. So let's go over some of the statistics as to actually how big your pile of moles would be if you had a mole's worth of moles. So if you had them just all in a clump, then you would see that this pile of moles, it would be about 1% of the Earth's mass. So if we had this furry ball of moles floating out in space as their own planet, it would be about 1% the mass of the Earth. So a big, big group of them. If we were to actually just put them out in space as a big furry ball of moles, it would be about 1.3 times the mass of the moon. So you could look outside at night and see just a big furry floating moon of moles. It would be 60 times more than the combined mass of the Earth's oceans. Now let's say you actually took your pile of moles and just wanted to carpet the entire Earth with that. So if you just laid down a full layer on the entire Earth of moles, and then if you had extra, you could just lay down a second layer around the entire Earth and just basically carpet the Earth in moles. So if you took your pile of moles and then just started carpeting the entire surface of the Earth, you could carpet it 8 million moles deep, which once again is a lot of moles. Other things you could do if you wanted to take your pile of moles and then line them up end to end to end, tip to tail, and just start at the Earth and make a chain going away from the Earth, you could stretch from Earth to our nearest star, which is Alpha Centauri, and then if you had extras, you could come back to Earth and keep going. And you could do that 2 million times from the Earth to Alpha Centauri and back with a mole's worth of moles. And then lastly, suppose that you had your pile of moles and you wanted to divvy them up into 6 billion equal groups so that every person on Earth could have a pile of moles. So if you took your pile of moles and wanted to share with everyone on Earth, and you just asked your moles to start going to every person on Earth, and they started walking away from you, and then let's say these people that were receiving your moles, they could count the moles as they came at 1,000 per second. So if everybody that was receiving moles around the world were receiving them at 1,000 per second as they just stood there and counted, then everyone on Earth counting at 1,000 per second could count your entire pile in about 3,000 years. So everyone on Earth counting 1,000 moles per second as your pile of moles divvied up, it would take 3,000 years for the population of the Earth to count out that pile. So moral of the story is a mole's worth is just a ridiculous amount as far as count goes. But the other interesting thing is if you have a glass of water, you easily have a mole's worth of water molecules in it. So a mole is a huge amount, but we deal with a mole's worth of things in very real, normal, everyday situations when we deal with atoms and molecules. So a mole is very big, but a molecule and atoms are very, very small.